Hey, what's up YouTube? Today we're going to be talking about L'Hopital's rule. So, over here on the left-hand corner, I know there are problems here, we'll get into those later. We need to review what indeterminate forms are first before we get into how we use L'Hopital's rule and what it is. So, indeterminate forms are forms in which we don't have an explicit answer and we don't really know what it means. For example, infinity is a concept, but we don't know what infinity divided by 0 is. 0 divided by 0 is the most common form of an indeterminate form. For example, 1 divided by 0 would just be undefined. 0 divided by 0 is simply indeterminate. Infinity divided by infinity is also indeterminate, and then you have all these weird examples of things that are indeterminate. However, this L'Hopital's rule is going to be used when the limit is equal to something that is indeterminate. So, for example, here, the limit of x approaching 0 of sine x over x. You just plug it in, you get sine of 0 is 0, divided by 0 is 0, so you get 0 over 0. The limit as x approaches 0 of x ln x is 0 times infinity, because you have 0 times ln of infinity is, ln of 0 is infinite, because there's an infinite line over here. If you just want to see the quick graph of an ln, it looks like that. So as you can see, when it goes to 0, it approaches some sort of infinite value. And then over here you have these weird exponents with 0 to the 0 power, 1 to the infinite power, infinity to the 0 power. The example here would be x to the 1 over x. Infinity to 1 over infinity is just 0. If you guys remember, the graph of any fraction, like 1 over x, looks like that, so as it approaches infinity, it approaches 0. Now let's go over what L'Hopital's rule says. And I'll do it in different color green on the top. So let's say I have the limit as x approaches some value a of f of x over g of x. So I have some sort of fraction set up. And the limit is equal to some sort of indeterminate form that can be expressed as 0 over 0 or infinity over infinity. So I'm saying that because if it's in these forms, then you're good to go to use the second part of the rule, which I'll go over in a second. However, if you end up with one of these forms, as you'll see soon, you have to restructure it so that it ends up as infinity over 0 or 0 over 0. If this is the case, then the limit is equal to, and what you're going to do is you're going to take the derivative of the top and divide it by the derivative of the bottom. Now, this is not the quotient rule. I know that's a common misconception, but you will be taking the derivative of the numerator and dividing it by the derivative of the denominator, so g prime of x. Sorry, that's a typo. And then you're going to have to do this again. If you end up with the 0 over 0, infinity over infinity, then you can do this again and you'll apply it as a second derivative, a double prime, so on, so forth, until you get an answer or you determine that the limit simply does not exist. So let's go over the examples here. This one is the simplest example. You already have it as 0 over 0 in this example here. So what we're going to do is we're going to rewrite it as taking the derivative of the top and then the bottom. The derivative of sine x is cosine x, and then the derivative of x is 1. So let's plug it in, and you get that cosine of 0 is 1, and then that's your answer. And as you can see, if we look on the graph of sine x, you're going to get something like this, where it's going to go up to the value of 1, but it's not going to ever reach it. So we can determine that the limit as x approaches 0 of sine x over x is 1 by using L'Hopital's rule. Now, the last two examples are a little bit more complicated because it requires that you rewrite them. So we're going to take this, and then we're going to rewrite it as ln x over 1 over x, because we have this in the form of 0 times infinity. However, what you're going to see is that what you're going to see is that you can just rewrite this, so you get a value here. 1 over 0 is going to be infinity. So now you have it in the form of infinity over infinity. And now we can take the, so we can take the derivative at the top and bottom. What you get is 1 over x, because the derivative of ln x is 1 over x, and then over the bottom is negative 1 over x squared, just by using your power rule. You can look at my past videos if you want to learn how to take these derivatives. And then you can simplify this by dividing them, and what you're going to end up with is negative x, and you just plug in 0, and you get that the answer is 0. So this technique, as you can see, is just rewriting this so that you have a fraction form. Now let's do the last one. For this one, I'm going to write it as y is equal to x to the 1 over x. Now, you're going to be seeing this a lot in calculus. To get this exponent down, you're going to want to take the ln of both sides. So we're going to take the ln of y is equal to 1 over x times the ln of x to the 1 over x. If you look at my video on introductions or the basics of the groundwork of calculus, it's the very first video I did on calculus. It's in the playlist. You will see that I went over these rules. I got trying to brush down the exponent. So the rule here is that when you have an ln of, and then in that argument, i.e. in the part of the ln, like what are you taking the ln of? If it has an exponent, you can just simply multiply it by it. So x to the 1 over x, you just bring down the 1 over x multiplied by ln x if you take the ln of both sides. And now this is in a fraction form, ln x over 1 over x. And now we can take the derivative, or not 1 over x, just, there we go, x. Now let's do top and bottom, 1 over x, because you have 1 over x here, and then the denominator is just 1, so 1 over x. And then you plug in your infinity, and you get 0. However, and this is the important part, we get that ln y is equal to 0, so ln y is equal to 0. So what we're going to do is we're going to rewrite it so that we just isolate y, and then we get that y is equal to e to the 0, and anything to the 0 power is just 1, or any number to the 0 power is just 1. So the limit over here is equal to 1. And so we have our answers. We have that for this one, it's 1. For the second problem we did, it's 0. And then for the first problem we did, the answer is also 1. If you have any questions, leave them in the comments below. I hope you enjoyed this video. Please give it a thumbs up and subscribe. And if you think your friends will also enjoy, please share the video. I'll see you on Monday.